Good afternoon, my name is Felipe Salamanca.
My name is Diego Salazar.
And my name is Andres Ovella. The future of nuclear fusion can possibly impact the status quo of the energy production on this planet. Now you may question, what exactly is nuclear fusion? Nuclear fusion is the process of combining two lighter atoms to form a heavier atom. This is in the process known as, here, deuterium and tritium are the lighter atoms and go under extreme heat and pressure and react together to form helium and energy, just like the processes in the sun. Now, a specific funding that promotes the production of nuclear fusion for the future is ITER. ITER has this experimental reactor called the tokamak reactor. Here, deuterium and tritium go under heat and extreme pressure to form helium and energy in this reaction process. Now, you may question, should the US government invest in nuclear fusion or other clean energy sources to meet clean energy demands 40 years from now? As a group, we answered yes, the United States should invest in in nuclear fusion to meet clean energy demands 40 years from now, because it would lead the United States to have less negative environmental effects, lead us to be more energy efficient, have us be more energy independent, and have long-term solutions for nuclear fusion. Now, as a team, we propose these solutions. First, we would use the processes of fission, wind, and solar for now, as nuclear fusion is in the process of being a reliable source of energy. Now, once fusion is a reliable source of energy in the future, because of ITER, we will switch from fission to nuclear fusion and combine it with renewable energy sources such as wind and solar.
As Andres mentioned, there are various reasons for the United States to invest in nuclear fusion. One of them being that nuclear fusion has virtually no environmental impacts. This is shown by Slawomir Endler, working at the Institute of Plasma Physics, where he describes the various external costs associated with cleaning up the environment after each energy source is used. For example, coal requires a large $92 per megawatt hour of energy to clean up the environment afterwards. This is due to the fact that coal releases a very large amount of potent carbon dioxide gas that needs to be cleaned up. Fortunately though, nuclear fusion only requires $0.9 per megawatt hour to clean up the environment. This is due to the fact that nuclear fusion's only environmental impact are the emissions associated with creating the reactor itself. Furthermore, an infographic by the US Department of Energy explains the byproducts of nuclear fission reactions and nuclear fusion reactions. They say that nuclear fission creates harmful and difficult to dispose of nuclear waste, while nuclear fusion only creates harmless helium gas. This is significant as since nuclear fusion only emits harmless helium gas, it can become a long-term solution to meet the energy demands without harming the environment. And not only does nuclear fusion have virtually zero environmental impacts, but it's also one of the most effective energy sources in development. This is shown by a textbook by Thomas Murphy, working at UC San Diego, where he compares the different amounts of energy released per energy source. For example, fossil fuels release an average of 10 calories per gram of fuel, fission releases an average of 20 million calories per gram of fuel, and fusion releases an astounding 275 million calories per gram of fuel. Although fossil fuels are obviously more abundant than uranium, nuclear fusion, as mentioned by Andreas, uses deuterium and tritium. Deuterium is commonly found in seawater, which means it's abundant in our oceans. Also, tritium, although more rare, can be synthesized from the same nuclear fusion reactions that use it. This is shown in the nuclear fusion reaction, where when a neutron releases from the reaction, it interacts with the tritium-breeding material in the reactor. This then creates more tritium that's collected in the tritium collection system to be used for future nuclear fusion reactions. This matters as it means that nuclear fusion can become self-sufficient.
Beyond those benefits, nuclear fusion also allows for the United States to become more energy independent. The United States, like many other nations, is heavily reliant on other countries for oil. For example, OPEC. Now, the problem arises because OPEC makes up 80% of crude oil reserves. This essentially means they get to dictate the price that the United States and other nations like it have to pay to get their oil. Luckily, nuclear fusion circumvents OPEC's oil monopoly by essentially allowing for the United States to produce its own energy within its own borders. This also allows for America's economy to become more centralized by decreasing dependence on nations outside of its own borders.
However, some may say that we do not need nuclear fusion as it has major issues and that renewable energies like wind and solar are all that we need to meet clean energy demands. For example, the latest nuclear fusion breakthrough happened on December 13th of 2022, where The National Emission Facility Laser, or NIF laser, created a historic nuclear fusion reaction where there was net energy gain. Unfortunately, those opposed to fusion would say how out of the 3.15 megajoules of energy released by the reaction, only 14 kilojoules was to convert into electricity. They would say this is significant because it shows how nuclear fusion still needs a long time before it can become commercially viable. Also, a study by Tian Guangwu, graduate from Harvard, explains how in India, an investment in wind and solar energy consistent with meeting 80% of their 2040 power demand would reduce carbon emissions by 85%. This matters as it shows how renewable energies like wind and solar can reduce carbon emissions by a very large amount by themselves.
Now, despite renewables being effective, they alone cannot meet America's energy needs. This is most readily displayed here. As you can see, with the yellow line displaying solar energy output and the blue line representing wind energy output, there are fluctuations throughout the year. These fluctuations essentially mean that there could be energy shortages depending on the time of year if we only use renewables. However, fission can fill the gap. As you can see here, fission has an impressive 92.5% capacity factor. Capacity factor essentially means how often an energy source can maintain maximum energy efficiency. And since fission has such a high energy efficiency, it can fill the gap left behind by wind and solar energy. However, fission alone cannot meet energy demands as well, because, as you can see here, while uranium demand has been decreasing, so has its extraction rates. So as we go along our 40-year timeline as we propose in our resolution, we will see that uranium reserves will start to deplete. So, hopefully, by the time we've reached the end of that 40-year timeline, we will have developed fusion technology enough to start where fission ends. And we will also be getting rid of the harmful radioactive material that is created through the process of fission, which is difficult to dispose of. This essentially means that fusion is a cleaner source of energy than fission, and will take effect after efficient uranium reserves run out.
This is true. As we transition from the use of fission, wind, and solar to nuclear fusion, the fuel for fission will go down in time, and we need to find a source of nuclear fusion so that we can meet our clean energy demands 40 years from now. And this is through the use of combining nuclear fusion with wind and solar to meet our energy production and have a safe environment. Now here in this graph by Thomas Amateur from the University of Munich, he stated that a combination of fusion with other renewable energy sources can help meet these needs and meet our energy productions 40 years from now, producing extreme amounts of energy such as 5,000 terawatts of energy, and this energy will be clean and not like fossil fuels which produce carbon emissions. Now with solutions, there are limitations. Our first limitation is the US government passing policies regarding environmental changes. This is hard as many political parties favor the processes of fossil fuels because they produce the most amount of energy right now in the United States. But other minority of political parties favor nuclear fusion as fossil fuels produce carbon emissions in the atmosphere. Second would be allocating funds for nuclear fusion programs. This is a limitation because many people wouldn't really rely on nuclear fusion to be a source of energy for the future and replace fossil fuels, as right now fossil fuels is our major production of energy in the United States. And third will be lobbying from fossil fuels, as this relates back to our second limitation, that many organizations would not agree with the United States to transition from fossil fuels to renewable energy sources and nuclear fusion, because nuclear fusion is yet to be a reliable source for the future. Thank you.
All right, Felipe, we'll start with you. Describe an argument from one of your peers' individual reports that makes you think differently about your team's solution.
So Diego actually had much of the basis of our argumentation, serving as the reason why we're implementing fusion to begin with, right, to mitigate the different environmental effects that have occurred because of the status quo of fossil fuels. However, it also made me realize that outside of the policy-making decisions and such, and also the United States' relation to other countries, that we also have to take into consideration things like smog and other, like the lack of air quality that results from the status quo, and that's not really something that I really discussed in my own report. So I think Diego's insight really helps my perspective on the entire issue.
Okay. Next up, what's an example of a compelling argument for one of your peers' reports that you decided not to use in your presentation?
I
why?
would say Diego's findings from wind, because first of all, when he researched about wind, we couldn't really find enough evidence to really support our argument that wind is a really reliable source over nuclear fusion and wind and solar, because first of all the data didn't really show that the energy production was a lot bigger than nuclear fusion, and that nuclear fusion is overall a more safer option for our environment, producing less carbon emissions.
Last up, if you had another team member, what perspective or limitations could they have reached that would have made a useful contribution to the project?
So I think through the ethical perspective would have been a pretty useful contribution, as it would have been a con for another con for fossil fuels that we hadn't previously described, where as fossil fuels like coal release large amounts of carbon, CO2 gas, it creates smog and reduces the air quality, that hurts the lives of individual people through lung diseases by inhaling the smog, and that would be an ethical dilemma. And that would increase our argument of how fossil fuels are bad for the environment.